What if I told you light could be made solid? I mean, literally solid. And what if a single experiment doing just that actually revealed a massive, deep flaw in the way we understand modern physics? Well, that's the really radical claim from our source material that we're diving into today. Okay, so get this. Forever, the rule was simple. Photons, the particles of light, do not interact with each other. They just pass right through one another. But then a 2014 experiment at Princeton seemed to blow that right out of the water, making light act like a solid. Now, our source for this explainer says this isn't just some cool new discovery. No, he argues it's a crack in the very foundation of physics. So here's our game plan. We're going to start with that solid light experiment. Then we'll get into the author's, let's say, sharp critique of what he calls fudge state physics. After that, we'll look at his mechanical alternative, see how it supposedly explains huge topics like superconductivity and the Meissner effect. And then we'll wrap up with the big picture debate, real versus abstract models. All right, section 1, the solid light experiment. According to our source, this isn't just another interesting result. He sees it as a direct contradiction to decades of established theory. And this is where the author really starts to throw some punches. He claims that the data from this experiment clearly clashes with foundational ideas like quantum electrodynamics, the whole theory of how light and matter interact. But did the physics community go back and question those old theories? He says no. Instead, they just sort of crammed this new contradictory data into the old broken models. And that leads us right into the heart of his critique. Welcome to what he provocatively, and I mean very provocatively, calls fudge state physics. So, you know the term quasi-particle, right? In mainstream physics, it's a useful abstraction. Well, according to this author, you can pretty much forget that. He defines it as a hole filler, a fudge. It's what physicists invent, he says, when they can't find a real mechanical explanation for something. In his view, it's not a particle at all. It's a placeholder for an answer they don't have. And he doesn't stop there. Oh no, he's got a list. He points to concepts like qubits, polaritons, phonons, and Cooper pairs, and calls them all non-physical fudges. To him, these aren't real things. They're just mathematical tricks that have been mistaken for actual physical entities. And he thinks this has pulled physics completely away from reality. So let's be clear, the author is drawing a really hard line in the sand here. On one side, you have real particles, photons, electrons, things you can actually measure, physical objects. On the other side, you have these virtual or quasi-particles, which he argues are just ideas, theoretical constructs that can't even exist on their own. They're just math. And this all boils down to one single massive claim. You cannot, he says, physically couple a real object, like a microwave resonator, to a theoretical idea, like a qubit. It just doesn't make sense. He insists that physics has to be about real things interacting with other real things, not real things interacting with abstract concepts. Okay, so he's torn down the entire house of modern solid-state physics. So what's he going to build in its place? Let's get into his proposed solution, a return to what he calls pool ball mechanics. The absolute cornerstone of his entire theory is this. He redefines charge itself. Forget what you learned. He says charge is not some mystical intrinsic property. It's a physical stream of real photons, photons that have mass and momentum that are constantly being pumped and channeled by the nucleus of an atom. And here's how he says it works. It's actually pretty simple. 1, charge is just that stream of photons. 2, the nucleus isn't just sitting there, it's an engine. 3, the protons on that nucleus act like tiny little fans, pulling photons in and pushing them out. So, in this model, electrical conduction is nothing more than atoms lining up their channels to create a highway for this photon stream. All right, so we have this new mechanical model. Now for the big test. Can it explain one of the biggest mysteries in all of physics? Let's see how he applies it to superconductivity. So the mainstream explanation for superconductivity is built on this idea of Cooper pairs. The theory that two electrons, which should repel each other like crazy, somehow team up and attract. Well, our author doesn't mince words. He calls that idea not physics, it is just hypnosis. He says it's just an assertion without any real mechanical cause. So if it's not Cooper pairs, what is it? Well, in his model, think of the nucleus like a spinning top. In normal conduction, it's spinning and channeling charge both out the top and bottom, pole to pole. and out the sides around the equator, like a carousel. But in a superconductor, that equatorial carousel spin gets stopped, forcing every single bit of charge into one super efficient pole-to-pole stream. And his model suggests two ways you could actually do this. First, super cold. You lower the temperature so much that there just isn't enough ambient charge or heat to get the nucleus spinning in the first place. Or, second, structural doping. You strategically line up certain elements to create a channel so powerful, so straight, that it mechanically forces all the charge to go pole to pole, stopping that spin dead in its tracks. Now, this brings us to a crucial test for any theory of superconductivity. Can it explain the Meissner effect? The author claims his model provides a simple, direct mechanical proof. So here's the million-dollar question. The Meissner effect is this weird phenomenon where a superconductor pushes out its internal magnetic field. But where does the field actually go? I mean, it can't just disappear into thin air, right? There has to be a cause. Well, the answer in his model is actually beautifully simple. He defines the electrical field as that main pole-to-pole photon stream. And the magnetic field? That's the equatorial carousel stream. So in a superconductor, remember we stopped that carousel stream. And according to this theory, if you remove the cause of the magnetic field, that spinning carousel, the field itself just vanishes. It's not expelled, it simply stops being created. And all of this, it really brings us to a fundamental clash of ideas at the heart of the author's entire argument. This is the final showdown: real particles versus abstract models. Ultimately, what he's really saying is that he believes modern physics has become this incredible, complex, beautiful castle in the air. He argues that physicists have gotten lost in explaining their own abstract mathematical models of reality, instead of explaining reality itself with simple, physical, understandable mechanics. And that really leaves us with this final, massive question to chew on. What's more important in science? Is it a model that perfectly predicts outcomes, even if it's just a mathematical abstraction? Or is it a model that claims to be physically real, something you can actually picture in your head, even if it means challenging a century of established theory? It's definitely something to think about.